Hello, everyone, and welcome to this next session. It is on a much anticipated feature for many developers, myself included, and you've seen it mentioned in other sessions throughout today and yesterday, TreeTable support in CAP. Allow me to introduce our amazing team of panelists from the CAP team, Adrian and Evgeny, who are both from the CAP Java team, and then we also have Olena from the CAP Node.js team. Let's give them a nice welcome.
Thank you very much. And yeah, my name is Evgeny, and today, together with my colleagues, Olena and Adrian, we will give an overview of what's currently happening in the area of TreeTables and how CAP support the TreeTables. Yeah, so let's start with that. As a small motivation, yeah, quite a while ago, we started getting feature requests from the stakeholders and the customers saying, okay, we have a nice TreeTable UI, but how can we use it in CAP? Can you please help us? And how can we write queries to extract the data and how this communicates with the CAP backend? Our first implementation or our first attempt was to use the existing APIs that already we have and to implement it in the custom code. And pretty soon we realized, okay, there are so much challenges that we have to deal with, like pagination, sorting. So you have not the plain data, it's hierarchical, yeah? So how you solve the sibling order, for example, sorting, or pagination when the client requests some chunks of the data, and yeah, you have to respond. And yeah, after some time, we decided, okay, this should be a part of the CAP backend, and both stacks, CAP Java and Node.js, do support that, and we do it for the local databases as well as for HANA, of course. Yeah? And we will jump to demo and have a look how it looks like live. For that, I've already started my application. The first demo, I will show the read scenario, how the TreeTable is rendered for the read-only scenario. Then after that, Adrian will explain what happens behind the scenes. And after that, we will see a more sophisticated scenario from Olena, how the managed case works. So it's our cloud sample application. Yeah, you know it. It's a bookshop. So we navigate to the genres. Here, if we click on the Go button, we can see that the first two items or nodes were selected. Now, what you can do here, of course, you can navigate through the tree. If you click on the expand, yeah, you can further and expand further nodes. Then, of course, yeah, you would say, okay, I want to see all the data. Yeah, how I can do that? There is an expand entire tree button, which will show you all the data that have the database. Nicely organized here. One nice thing, as I already mentioned, you don't see it here, but if we will go to the console, we'll see that there are two consequent requests from the client, from the UI. The difference is that the first request requests some data. Okay. The first request says, okay, I would require 231 elements of the nodes. And the consequent request says, okay, I will skip during the scrolling. You didn't see that, but the UI sends the consequent request that says, okay, skip the already read data, and I'm interested in the rest 38 rows. And this is now all 269 rows are rendered here correctly. Now the next challenge would be, okay, I want to do the sorting, how I can do that, yeah? Click on the sorting, sort it in descending order, and here you can see that not only the parent nodes are rendered correctly, but all the children are also, so the descending sort order is applied to the children correctly. Yeah, the interesting part is also the searching and filtering. So here, yeah, maybe one thing to mention that if you apply search and filter, you will see the so-called filtered tree. Yeah, it means that only those nodes which match the filter condition will be shown here. What I mean, for example, with the sports, yeah, we can see that sports node has a soccer, yeah, as a child. But what will happen if we do a search? So sport, we can see that, yeah, for some reason, sports is now a leaf. Yeah, it's not the bug; it's actually a feature. This is what is implemented by the UI and how this request is implemented and supported by a CAP. Same also applies for the filtering. Now, that I want to filter only the nodes that meet this condition. I will see that the sports is rendered, and it's the only one node with its parents, of course, that is shown here. Another nice feature that we also can demonstrate here, that you can reuse this logic and the components. Yeah, actually, if you go to the manage books and click on the go, we select some book, the cat weasel, and we want to edit the book and change the genre. We click in the edit, go to the general section. Here we can see that the currently fantasy, the genre. Yeah, I click on the object value help, and here we can render this tree table as well with all the data. Okay, click on that. Yeah. Okay, and we want to change it, I don't know, to, yeah, imagination was happening, to family drama. Click save. All the changes are applied. So with that, I guess I would like to hand over to Adrian to explain some details happening behind the scenes.
Okay. Thanks, Evgeny. So let's look a bit behind the scenes. And so in the log output, Evgeny has briefly shown, if you had a very close look, you saw a request, well, like this one, which I'm currently showing. But I want to activate the laser pointer, this one. And it does not look like the OData request you all might be familiar with, because it uses here this apply, and then it uses this top levels transformation, and then here it specifies some particular nodes which need to be expanded. The question is, why is this all so complicated? And the reason is because we have a very stateful UI where you can like expand nodes, where you can change the sibling order dynamically, where, as Evgeny already mentioned, while you're scrolling, pagination happens on the background. The UI needs to display details on the nodes like the drill state. So these little triangles need to be well, directed in the correct direction to indicate whether you are a child, an expanded node, or a leaf node. And then, of course, we need to do this tree traversal. We can't just do plain expands for different reasons. One would be because yeah, we don't necessarily have an association to all children nodes. And the other reason is that, unfortunately, because we need to also support the pagination requirement, we have to execute everything with a single query. So we can't do this, as Evgeny already mentioned in the introduction, with custom handlers and custom code after the data was retrieved. It really has to be a single SQL statement which is executed. So how did this? How was this all designed? As mentioned already, the UI talks to the backend using OData, and OData has this extension for data aggregation where the system query option apply is coming from. And in the year 2023, this extension for data aggregation was received a new revision, the revision 3, and there the notion of recursion and recursive hierarchies was introduced, and also like transformations like ancestors and things like this. Then this again is augmented with a vocabulary. There are two parts, a standard or ACES vocabulary, which allows you to define annotations to specify a recursive hierarchy. And then there are also UI5 specific parts which did not make it in the OData standard. And for example, this top levels transformation, this is part of the UI5 vocabulary hierarchy. So these are kind of the ingredients which we have to deal with. And I mean, I guess you all attended the keynote today where Daniel already presented that what spans a hierarchy is essentially a parent association, in this case, named or also parent, which points backwards to the same entity type, in this case, genre. And then we need to have like an annotation, this recursive hierarchy annotation, which tells the UI that this is the parent navigation property, and that the property named ID identifies a node uniquely. But it also tells the backend that if we receive a request with a hierarchy named genre hierarchy, these are like the two identifying properties which know us how to like wire things up in a recursive way. Then we have these additional elements which we so far still need to declare in an annotation, in a model extension. Very important here is distance from root, how far you are from a root. Limited descendant count, this is how many nodes are transitively be under a certain node, and drill state, whether a node is expanded or collapsed, or whether it's a leaf. And then also we have all these UI annotations where we again tell the UI that what the names of these particular elements are, and that the UI better should not like sort or filter with them because they're only for display purposes. All this, as Daniel mentioned in the keynote, is going to vanish. This is what's going on behind the scenes. They are not going to vanish from the EDMX model, so the UI still needs all this information. Currently, if you're using CAP Java or CAP Node in the current release, you need to use these annotations. In a release sometime later this year, we plan to reduce this to this at hierarchy annotation. So as it stands, we can convert these pretty complicated OData requests to SQL. And we started with doing so on HANA because this is, of course, our go-to database. And on HANA, we have very powerful hierarchy functions. So here is a hierarchy generator function. Here are functions to determine the set of ancestors of a node in a hierarchy. Unfortunately, on other databases, these hierarchy functions are not available. So we can't use them. They're proprietary to HANA. But on other databases, we have recursive common table expressions, which we can use for similar purposes. On the other hand, HANA does not support recursive common table expressions. So we are really forced to not only generate pretty complicated SQL, but we also need to generate it in a very vastly different way for HANA and for other databases. But as of now, CAP Java is supporting HANA and H2 since recently. Postgres will follow next very soon. CAP Node.js supports HANA and SQLite and also Postgres. So this is what's happening going on behind the scene. And now I would like to give Olena the opportunity to present hierarchy maintenance on CAP Node.js, which is actually a brand new feature which the CAP Node.js team released only with this very most recent 9.1 release.
Node.js side. In this final part of the presentation, I'm going to show you how can you modify your recursive hierarchy in two scenarios, list report and object page. I will start with the list report. And with create. So creating a root node is really, really easy. You just need to click on this create button. To create a child, you need to choose a parent first. So I am going with Romans, for example, here. Click on create, type a name for my new child node. Going back, and you can see that there are just two options available to me. So either I can create a new node or discard the draft. Of course, I'm going with create. And here you can see that the new child node is successfully created and correctly assigned to a parent Romans. So now if I changed my mind or because of any other reason, I want to reassign a parent. So for example, I want my new child to be a child of cozy mystery. Just via drag and drop, I can easily do it. Cozy mystery. So it's disappeared from the Romans as a child, and you can see that it's correctly assigned to cozy mystery. So another thing which is available here, you can modify an existing node. Let me take something deep relatively. So I'm taking this dystopian node, going to it, click on edit, changing the name. And if I'm going back now, you can see that I have a third option available, keep draft. I'm choosing this one. And as you can see, we have a cute little icon here, which is showing me that there are some unsaved data for my dystopian node. Keep in mind that on list report page, every node is an individual draft. So which means that I can modify any node, every node separately. More about it in a minute, but for now, let me try to delete a parent of my dystopian. Yeah. So no, I cannot do it because a child draft exists. Easy to change. And I'm trying to do it again. So now it's deleted, so everything works. Let me quickly change to the slides. So not slides. Just one sec. No. Okay. I found them. Thank you. And here we can see this our genre entity that Daniel shown on the keynotes today. And what I want to point out here is that you can see that we are using composition of many for the children. That's why the delete that I've shown you before was a cascade delete. So a node together with its children was deleted, not just the node that I choose. And another thing here, you can see that the list report page is modeled this way, that my entity genres has no other parents except for itself. That means that, again, so every node is modifiable. Every node is an individual draft. Why I'm stressing this out? Because this is the main difference between a list report page and object page. So here we have an object page. And you can see that we have two entities here, an entity books and recursive hierarchy contents. And the relationship between them is a composition of many modeled on the book side, which means that books is a parent in my case, and contents is a child. And this leads to that on the object page, we have just one draft for the whole hierarchy. So, and this draft is owned by books. I will show you in a minute. You don't need to believe me. So I'm going to books. Hope it's still, yeah, it's not just. Okay, choose any book I want. So for example, this one. And as you can see, so we are now on the book object page with recursive hierarchy contents embedded into it. it's a recursive hierarchy. And you can do, if I click on edit here, the one draft, as I mentioned before, is created for the whole hierarchy. So I can do similar things here that I did on the list report page. So I can modify something, don't know, delete something. I can also create nodes and reassign a parent. I will not do it for the time's sake, but when I click on the save here, everything, so every modification will be saved at once. So it's one draft. So I think that's almost all. So a short recap. And presentation. So UI5 TreeTables are now supported by both backends, Java, CAP Java, and CAP Node.js. Everything we have shown you today is available out of the box. No special and additional coding is needed. And CAP Java supports recursive hierarchies on H2 and HANA, and Node.js on HANA, SQLite, and Postgres. So I think that's all from our side. I hope you are now very excited about recursive hierarchies. So thank you for your attention.